Alright, so here we're trying to find the centroid of a figure, which is something that we don't definitely know what it is. If it to be, let's say, a square, a square, sorry, a square, a rectangle, something, or a known figure, most of the time there are equation describing this. But this here we're trying to use the differential method. We're trying to find the centroid. When we are trying to find the centroid, they're using the integral method. There's basically few things that we are looking out for. We are looking out for, if let's say you're finding x, we are looking out for, let's say, an a and then this, right? And then we are looking out for this, right? So the same for y, something like this, and then this, right? Right. But because we're using integration to be something of this sort, where we have we have a dA all over this, and then you have a dA, the same thing for this, you have this, and then we have a dA, and then we have a this, and then we have a dA, right? Before we do any of this, it's very important that we get this and then we get to know what we are looking for, right? But here's the case in this particular question. Here's the case where we are trying to find the centroid, right? And then the instructions are very specific. We are finding what a vertical differential element, right? What this means is that we're actually creating a vertical differential element, something of this sort, right? This is what we are doing. And then when we create something like this, it means that the thickness of an element of this sort, differential element, the thickness something of this sort, sorry, a very small x, which is let's say the x, right? And then this equation here is what's describing the whole of us here, like the curve. Any point on the curve can be described using this equation, right? So, what is saying that I find the center? It's much more easier to go by this. The moment you see the x this way, meaning that you are doing the integration with respect to x, right? That's one thing to have in mind. Let's say here's the case where we are doing what do you call it? We are using just a vertical differential element, right? So let's say we try finding the let's see x first, right? The s component first, or the center first, right? This should be something. It should be this way. We have integration, and then we have x, right? And then we have a dA or what? And then a dA, right? So now we know that because we have created a very small differential element, we are doing the integration with respect to x, right? But then the area of this of this small differential element that we created here is this thickness, right? So let's say this area, the area of differential element. So it's written this way. Now we're trying to find each and every term. So this area here, this differential element here. So this the a here. The area of it is actually the x, right, times the length here. So let's say from here we know this side. So if it's some sort of a rectangle, right? So it's like length times breadth something. We know the breadth, which is this dx, and then I will need the length. The length here, let's use some letter. Let's see h, right? This h is from here to here, right? This is a h. But then we know this h to be at this point here is the at this point any point on this curve here is described by this equation. So let's say h is kind of like y. So if h is y, we can make y the subject, and then we end up getting everything in terms of x because why? We are doing the integration with respect to x, right? So let's say this whole thing here will be y is equal to uh, y is equal to advanced 2 by 25. That's 2x, right, minus x squared over 25, which is y, which is the same as our h, right? This is our h. So the area here that we are finding will be what? So this a times the x. Now we know the h. This is the h. What are we getting? What are we getting? That will be 2 2x minus what? X squared over 25, right? Dx. Now we have the area, right? Yes. One thing again too is that the reason why we see a differential element is that we've created a very small area. So if we are picking an x among it, it is very small to the extent that when we are trying to pick the center of this particular figure is the same as x. This thing is very important because at times you have to create the conventions whatever it is that you are doing, right? So if we try to pick an x within this figure here, it's so small that we don't actually have to do anything. It's just the same as any x that we pick, right? So the center along the center of that differential element here in terms of x is just x, right? Okay, so we have that clear. So we have the area, we have the center. So now find the x is easy. So let's see. X is this. The integration to x, right? So x, we know that this x bar on it is just x, so let's go back. And then we have a dA. We know the dA to be this, which is 2x minus 1 s squared 25 and the dx, right? All over what? We have a dA, right? This is the dA again. That will be 2x minus x squared 25 all on what? Dx. When you get to a point like this, your work becomes easier if you do them one after the other, right? So now let's try and do the top side first. Let's see. So that'll be x, right? We have on the side 2x. Okay, let's just write this 2x minus x squared 25, right? Dx. So basically, this is something like our kill, right? If you look to rest stuff like this our kill. So we end up getting 2x squared. We're integrating all of this minus s cubed on 25 dx, right? One thing to notice is the limit of integration. Then again, why? We've created a vertical differential element. The thickness here is dx. That's why we're doing the integration with respect to x. Then we have to look, because we are doing the integration with respect to x, our limit is from where? 0 here to what? 50. So 0, 50, 0, 50. The same thing here. So 0 to 50, 0 to 50, right? Yeah. So now we are here. So this is what will happen. When we integrate this, we get to power 3, so 2 on 3, x to power 3, x minus, this is actually 25 and minus 1. Right, so 125 times 104. But I get why I'm doing it this way to make my way my work easier. And x to power 4, right? And then this, right? T0 and then 50, right? So let's see. Okay, let's do it. When you get to break them down individually that way and then you go step by step, you get to know what you are doing. Yes. That way your work becomes much more easier. 2 minutes. Okay. So whenever you create a vertical differential element, mainly you are doing the integration with respect to x, create a horizontal, you are doing the different integration with respect to y, right? Remember it that way, makes your work smooth. Oh, I'm trying to, let's see. Okay, so that'll be, so when we do this, it looks like we'll be losing the zeros. So just have separate 50s. Okay, see. If I when you get here, depending on how the examiner is looking for what you are doing, you can just solve the particular point and then point it closer to the answer. So that's what we are getting. Alright, so when you get here, you can just do directly. So you have a 0 here, then you have 50. Right? So this will be x, right? In the bracket. I'm just punching words here directly, but if it were to be manual, I would have done just that directly. So that will be 2x, and we have a minus x squared, that's x. Let's just get to this. So we have a 0 here, 15, and then we have an x, and we have to bracket 2x, and then a minus fraction of an x squared. We have an x squared, and then we have 25. Right? So integrating this gives us 208, 33, and then 33 we carry, right? This way I get it. This gives us the Q. That meaning that when we know that this Q is a x bar like this, so in terms of dimension, it will be the units, if we let's say it's millimeters, the millimeters cube, right? Or just millimeters cube, that's all. That's right. So that'll be millimeters cube because this is 2, this is 1, right? Yeah, so we have it for that one. Now, our aim now is to. Alright, so now we know that this right, ax, right? So what do we need? We need the area, right? We are x now, so we need this area here. So that's what we get to. So to get that area, we need it to be this way, which is and then the d, right? And then integration still with respect to x, so 0 to 50, right? 0 to 50, right? So, and then the dA. We know the dA to be this, right? 2x minus x squared and 25, right? So that's 2x minus x squared and 25, right? And then I want dx, right? Let's confirm this. Exactly. So yeah, that's what we have. This one's just straightforward. You can just get it here. So let's see. Okay. From 0 to 15, 0, 15, what do we have here? We have 2x, and the minus function is x squared, and we have 25. And that's what I get. So this is the area, this 8, 3, 3.33 we care, right? So it's because an area, get what? Square, or unit square, right? So now let's see. So clearly now we have the x coordinate, right? You can actually get the x coordinate. Then again, because here we are using the same differential element, we don't have to calculate this dA twice, right? Because initially our aim is to what? Is to find x and then y, right? And then we know x. Looking at them here, we are using the same differential element, so the area of it is the same. And now we have the x side, right? We have the area, we have this. So the only thing to find here is this, right? Let's see. Integration of y dA. Here is where something we must look at it very well. So now let me clear this up so we can see what's happening. Alright, that works. Right. Let's see. Okay. Then again, the same differential element, right? So we're doing the integration with respect to what? X, right? So right now our aim is to find what? Y, this, and then the dA. We know the dA already, we need y. Now our aim is to express every y there in terms of what's the name? X. right? So in order to get the y, right, which is the center of this in terms of y, what happened? It's actually to get this is like this everything here minus 0, right? The point here minus this. That gives us the height. We actually need half of it, right? So we actually need h on 2. But we already expressed h to be what? This 2x and then this height. We actually to get to the center of it, we actually need half of this height, right? So to get y, we need h divided by 2. And then we know h to be 2x minus what? X on 25, x squared on 25. Let me write this out well. So 2x minus what? X squared on 25. That's what we need. That's actually h divided by 2. Right. So that gives us our y. So meaning that this center y will turn out to what? Well, over 2. So let's see, that will be x minus what? X squared on what? 50, right? Use as our center. So now we move on. You are still doing the integration with respect to what? X. So from where? 0 to 50. And this is our y. Our y is what? X minus what? X squared on what? 50. Get why I did it this way? It's like I'm dividing this by 2, right? And I'm dividing this by 2. So that's why I multiply here, making it 50, right? That's why is this. So now let's move on. Now we know why we are doing it that way, right? Now we have y. We need the a, right? Oh, I cleaned that one up. Let's see. So that's y. So now you know the a, which we have already to be, what's it? 2x minus x squared 5 dx. Let's see. Now let's clear this up. Yay, nice one. So yeah, we need the a, right? Which is 2x minus x squared or 25 but dx. Here is where you have to expand and then to make the work easier for you. Just go. Oh. So let's see. So that will be 2x squared minus x cubed x cubed on 25. I'm doing this and then this. Right. And down that one. So right now I need again. I need this, so that will be 2x cubed on 15. Then I just did this. Now I'm going to do this. That will be minus plus. So this, that's plus, that's negative. I'll find that. And then we have this, the same thing. This and this. This negative is here. Then we have this positive. Oh, let me clear this up. One at a time. So you can see what's happening. So this function, if you're using a calculator, is not necessary. So let's see. But I'm just trying to show what's happening. So that will be 2x squared. I'm doing this. Right. Now I'm doing this. That will be minus s cubed on 25. Around that. Now I'm doing this. That will be minus 2s cubed on what? 15. Right. Now I'm doing this. Minus one, that will be a plus. That will be s4. And then 50. 75. Right. This is where I get it. The x. So now that you have everything is with x, you can go straight for the integration. Right. So now that we have this, we can just do straight for it. The limit is from 0 50, 50. And then we have here, we have 2x squared, right? And then we have a minus fraction. We have an x cubed, right? And then 25. And we have a minus fraction to x cubed, and then 250. It's up to you to simplify it if you want, but like if you get to this point and then the examiner allows or whoever is examining allows you to do this, you can just go straight for it. We have an x power 4 power 4. See, power 4. Then we have 15 and a 25. So this is what we are getting. Okay, this is what we had. And then again, this is for what? This is this y the a, right? Which you know to be q. How about the y-axis, right? This one is actually written as x. Let me write it all. I'm getting confused here, but if it were to be I, you have been this way because it's x, because this y, you have been about the x, but forgetting about this one. But we have the answer. So now let's see. Let's write it down. We have getting this to be targeting 8, 3, 3, 3, and then recurrent, right? Then again, this is q, right? So which is we know to be ax this, so meter q, right? That's what we have. So now we have that. So we can just go ahead and then find the coordinate and the x point and the y point of the coordinate, right? Now let's see. Find an x. X is this, and then this, right? Let's see. Let me write this word so I don't get confused with it. Here's the x. Let's see. What did we get for that one? Yeah, we had 20833 and then 33. Okay. 20833 okay. So for x, you have 208. Let me write this someone. So for x, yeah, 20833 point carrying, and then we have the area to be, we have 833.33 carrying. Now let's see this one. Let's write up to down so what is that one? Yes, so we have that one to be 833.33 current. Eight. Yeah, so now we have this. So that will be 208. So that will be 208.33. And then the A is what? 833.33. We're not getting, we'll do that later. Y, AY, this, and this. Let AY to be 833.33. This is just calculation. Now we get the concept. You can just put everything in and then you'll be done. I just want to get this to a completion so that you can see what's happening. So let's see. So we are now getting an x. Now we end up getting a y. So now let's do computations. See what we are getting. Okay. So for x, what do we have? We have 208 point 208 point 8. And then we have 833.33, right? That gives us 25 approximately. Right? And then y. That's 8333.33. And then 833.33. That's about 10. Yes, so that's about 10. The units are very important, right? And at times it can be weird, but you just have to write the center you're looking for. So the C for the center, the centroid, is equal to write them in terms of points. X is what? 25. 25 mm. And then Y is what? 10 mm. So let's see if we're on the right path. If we are not on the right path, then we assemble. Let's see. Let's get this. So there's a question. Yeah, so we are on the right path. Exactly. Right.